Okay, so good morning. So our lesson for today is all about direct variation. Okay, so when you say direct variation, so we are talking about two or more variables, two variables. So we have the independent variable and dependent variable. Okay, suppose we have here y is equals to kx. So we have here the variable y and the variable x, where k is our constant of variation. Okay, so we have here example. Suppose y varies directly as x. So we can write the equation of this variation as y is equals to kx. K multiplied by x, where k is our constant of variation. Okay, so we say direct variation, so we can have, for example, you are working, isn't it? The number of your salary will depends upon the number of hours you are working. So that's an example of direct variation. So another example is the distance traveled by a car depends upon the time or how long you traveled. Okay, so later we will give example about that. So we're focused here. So suppose y varies directly as x. So what is the constant of variation? If y is equals to 54, when x is equals to 3, so we are going to solve first now the constant of variation. So it is represented by a variable k. So we have here to solve for the constant of variation, we are going to substitute. We have y is equals to 54. So this is 54. We just replace y with 54 equals, our x here is 3. So we will just multiply 3 by k. So it would be 3k. To solve for the constant of variation, so we are going to divide both sides by, we have here 54 equals 3k. So we are going to divide both sides by 3. Okay? So therefore, our constant of variation now is 54 divided by 3. That would be 18. K is equals to 18. Isn't it? We have y is equals to kx. So we can determine now our equation for direct variation. So therefore, this will be y is equals to 18x, where 18 is our constant. Suppose we are going to solve for the value of x when y is equals to 144. So in solving for the unknown variable and the given, we have here the given y is equals to 144. So we are going to use our constant. That is the purpose why we are solving the constant. We have here, we are going to use same equation. So we have y is equals to, isn't it? Our constant is 18x. So we are going to substitute y here. We have 144 equals 18x. To solve for x when y is 54, so we just divide both sides by 18. Okay? So we have here 144 divided by 18. So therefore, the value of our x here is 8. When y is equals to 144. Okay? So let's have another example. So suppose y varies directly as x. So we are using same equation. We have y is equals to kx. Again, first we are going to solve for the constant. So here are the given. y is equals to 1/3 when x is equals to 2/5. So let us substitute the value of y and x to solve for our k. So we have y is 1/3 equals x is 2/5 multiplied by k, so we have 2/5 k. Okay? To solve for the constant, we have here fraction already. So we can just multiply both sides by its reciprocal of the numerical expression. We have 2/5. So this would be 5/2. So on the other side, we will also multiply by 5/2. So therefore, we can solve now for k, or our constant. K is equals to, so we just multiply 5/2 by 1/3. So this would be 5/6. So this will be our constant now. Okay, solve for x when y is equals to 1/4. Okay, so to solve for x, so we are going to use our constant that we have 5/6. So our equation. So our equation now would be y is equals to our constant, we have 5/6. And then our y now is 1/4. So we're going to substitute to solve for y. Okay, again this y is 1/4 and our constant is 5/6 x. So we are solving for x. So therefore we are going to multiply both sides by the reciprocal of 5/6. So this would be 6/5. On the other side we also have 6/5. Okay, so the value of x now would be 6 times 1. So we're going to multiply 6/5 by 1/4. So this would be 6/20, or that is 3/10. So x is equals to 3/10 when y is equals to 1/4. Okay, let's have another example here. So we have here number 3. Suppose v, we have the variable v varies directly as g. We have two variables here, v and g. And v is equals to 36 when g is equals to 4. Solve for v when g is equals to 11. So first let us establish our equation. Suppose v, so we have here v is equals to varies directly as g. So therefore we have v is equals to kg. So let's solve for the constant of the variation. So we just substitute v, 36 equals, our g here is 4. So it would be 4k. To solve for k, so we will divide both sides by 4. So we have now our constant, 36 divided by 4. The answer is 9. Okay, since we have already our constant of variation, so we can solve now our v when g is equals to 11. So our equation now will become v is equals to 9g, since our constant is 9. So we are solving for v, so this would be 9 times 11. Since G is equals to 11. So therefore we have V is equals to 99. This is our answer. When G is equals to 11. Okay, so last example. So we have here the distance. For example, we have here the distance traveled by a car varies directly with time. So the distance, we have the variable B. You can use variable B for distance. Varies directly with time. So we can use the variable T for time. So our equation here would be D is equals to K over T or time. Let's solve for the constant of our problem. Since the car travels to 320 kilometers in 4 hours, so let us substitute D is equals to 320 and our time, so we have 4 hours, so it would be 4 times K. K is our constant. Okay? So we will divide now both sides by 4 to solve for the constant. So we have now K is equals to 80. 80. This is the constant. The question here is how long does the car travels if it travels for 10 hours? Okay, so using the equation, we have D is equals to K multiplied by time. Okay, so we have D. So we are asking about the distance if it travels for 10 hours. Okay, so the distance would be D is equals to the constant 80. Then we are traveling for 10 hours. So that would be 80 times 10. So the distance traveled would be 80 times 10. So that would be 800 kilometers. Okay, so that would be direct variation. So when one variable increases, the other variable will also increase or decrease. So just like for example, the distance traveled by a car varies directly with the time. And also we have, for example, the salary depends upon the number of time